Okay, so this problem is not on this worksheet that we have right here. We talked about this problem, we talked about that problem. I just did this one. I'm about to do that one. So I just wanted to throw it out there, make sure you're not getting confused. This one that I'm about to work right here is not on that sheet. But I wanted to give you one more example. I will do that problem. It's right here. I will do that next. But first, I wanted to do this problem again. This type of problem again. So here I have named event D. I have named event D to be the event of drawing a card from the deck and that card being a diamond. So I've taken all of the diamonds out here. This is all 52 outcomes. This is the sample space. That's what the big rectangle represents, the sample space. All 52 cards are represented somewhere up here. These are all the diamonds. I defined event S to be the event of drawing a card and it being a spade. So I put all of the spades in this circle. And these circles are going to remain separate because there is no element of this circle set of numbers, this circled set of numbers, that is also in this set. These two circles are completely separate from each other. They share no common cards. You can't be a diamond and a spade at the same time. So since there are no shared cards in that, a card that belongs in this event and in this event, these are considered mutually exclusive. And since they're mutually exclusive, to find this probability, the probability of drawing a diamond or drawing a spade, all we have to do is find the probability of drawing a diamond and then find the probability of drawing a spade and simply add those two numbers together. That's all we have to do. So how many diamonds are there? There's 13 out of the total of 52. How many spades are there? There's 13 out of 52. So the probability of me drawing a diamond or a spade is simply 26 out of 52. Now, leave them unsimplified, in order to add them together. But once they're added together, be sure you always simplify that answer. So the probability of drawing a diamond or a spade is 1/2 or 0.5 or 50%. And that should make sense because we're talking about half the cards, right? If we're talking about the suit of diamonds and the suit of spades, if I draw a card out of a deck, it's 50-50 that it's going to be either a diamond or a spade. So that's how to do mutually exclusive. And that seems very straightforward. You simply add them together. What's the probability of getting a diamond? 13 out of 52. What's the probability of getting a spade? 13 out of 52. You just simply add them together. But in this one, which is this example right here, is on this worksheet. It's right here. This is a card is selected from a standard deck of 52. Find the probability that the card is a face card or a heart. That's the one that I'm doing right here. This is a face card right here or a heart. So what I'm finding right here is the probability of a face card or a heart. And that's, of course, I've defined event H to be the event of picking a heart. And I've defined event F to be the event of picking a face card. So here's my sample space right here. It has 52 of the cards in it. All 52 cards are there. And in the heart circle, I have listed all of the hearts. The ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, King, Queen. And over here in the face cards, I've pulled all the face cards. Jack, Queen, King of Hearts, Jack, King, Queen of Diamonds, Jack, Queen, King of Spades, and Jack, Queen, King of Clubs. So I've got all the face cards in there. But this time, because we have this set right here, this group of King of Hearts, Jack of Hearts, and Queen of Hearts, those three cards fit in this set, in this event, and they also fit in this event. Those three cards belong to both events. So this means that these two right here are not mutually exclusive. Not mutually exclusive. So since they're not mutually exclusive, this is the formula that we're going to have. So because understand that if I just find the probability of drawing a heart and I add it together with the probability of drawing a face card, I'm going to count the card. I'm going to count too many cards. So right here, the probability of drawing a heart is all of these, and that's 13 out of 52. The probability of drawing a face card, that's 12 out of 52. If I just simply add those two together, I'm going to get a total of 25. And if you go in here and count these, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, I only get 22. So why am I, if I find the probability of heart and add it to the probability of face card, I'm going to get too many. I'm going to get 25 when there's really 22 in here. Why am I getting too many? Because I'm counting these twice. I counted them when I counted the hearts, and then I counted them again when I counted the face cards. So that's why I have to subtract out that set. That's the probability of heart and face cards. I have to subtract that 3 out because I've already counted them. I counted them when I counted the hearts, and I counted them again when I counted the face cards. So now I've got to subtract them out of this sum total so that I don't get them counted twice. And when I do 13 plus 12 minus 3, I end up with 22 over 52, which is the correct answer. Now I know that that simplifies down to what, 11 over 26? And 11 over 26 is going to be, can be written just left as 11 over 26. It can also be written as the decimal, and I put a little wavy sign right there because I'm going to round 0.423, and that can be rewritten as about 42.3%. So be able to write the answer or see the answer in one of three ways. You've got this, or the decimal, or the percent, the fraction, the decimal, or the percent. So I hope it's a little bit clearer now when they're not mutually exclusive why you have to subtract that out, because they're being counted twice when you just add those two together. When they don't share anything, like these two, they didn't share anything, we don't have the trouble of counting anything twice because there was nothing in the shared space. So just understand that this shared space right here, let me highlight it, this shared space right here, that shared space in there is always the probability of these two with the and, H and face card, hearts and face card. This is the and right here. Okay, so that we've understand that now, I did go ahead and draw the two Venn diagrams, and you can do it, but you don't always have to draw a Venn diagram. Sometimes it's just obvious, like for example, find the probability that a donor selected at random has type O or type A. So for problem number 1 right here, there's the word or. So the probability of O or A. So or should tell you to add. But what I need to know is, is this mutually exclusive or not? So the question is, can you be O blood and A blood at the same time? The answer is, so can you have O and A blood at the same time? So in other words, if they check your blood, will it come out O, and then another time will it come out A? Can you have the same blood coming from one arm test two different types? And the answer is no. You cannot have both types of blood unless it is just some sort of crazy phenomenon, like maybe you got bone marrow transfer or something and it changed your blood type. I don't know. I'm just saying that under normal conditions, no, you do not have type O blood and type A blood. You're one or the other. So since the answer is no, these are mutually exclusive. So in other words, this would be type O blood over here. This would be type A blood. So how many do we have that have type O blood? Well, we have 156 that have positive and 28 that have negative. If you want to separate that inside this, you can. So you can write 158 over here, 156, sorry, and then 28 over here. That's a total of 184. And A blood, we have 139, and then we have 25, but still there's a total of 164 in that one. So the total altogether in the entire sample space right here is 409. So there's 409 people in the sample space, and all of these other people that we didn't count are sitting around out here, 45 out here, 16 out here. So there's a total of 409 people in this total sample space. So since they are mutually exclusive, all we have to do is add them together. So the probability of getting O blood plus the probability of getting A blood, or having O blood and having A blood, probability of having O blood is 184. Whoops, I'm not using the symbol. 184 out of a total of 409. And the probability of having A blood, there was 164 out of the 409. So you add those two together, and it comes out to be 348. Those two added together over 409, and then that reduces down to about 0.851. So I don't know if that will reduce or not. I don't have my calculator, don't have that information. But anyway, there's the decimal value, 0.851, and that's about 85.1%. Okay, so the next question says, find the probability that a donor selected at random has type B blood. So here we want type B. Okay, so this event is type B blood. And for type B blood, we have 37 and 8. And then it says, or is RH negative. So I'm going to say the probability of having B or having negative. So my question is always the same. Can I have type B blood and have RH negative blood at the same time? And the answer is yes. Yes, you can. Here is RH negative blood that's also B blood at the same time. So what that means is that my circles are going to intersect. So I need to take this circle right here, and I need to move it over, because 8 is just a part of a total of 65. So if I take 8 away from 65, then the rest of these over here in this negative This is negative. I have a total of 28, 25, that's 53, and then 4 more, that's 57. 57 and 8, that would be a total of 65. So I've got 57 that are negative plus the 8 that are negative right here. And then I've got B blood, 37 that are positive and 8 that are negative. Okay, if that messes you up, then just erase that 57 right there and put 28 and 25 and 4. And then when you add all those up, you'll get, should get 8 plus 28 plus 25 plus 4 should give you a total of 65. And remember, all of these other numbers are out here. So this is 184 O types, 164, actually 156, because we've got the negative ones in there, 139, and 37 and 12. Those are all out here because together, remember, we have a sample space of 409. So if we add the probability of B blood, which is a total of 45, if we add that together with 65, we get 45 plus 65, we get 105. That's going to be too many. Why? Because if I add these two up to get 45, and I add all of these negatives up to get 65 right there, then do you see the number that I've counted twice? If I add 37 and 8, and I get 45 right here. This is 45. And I add these two together, or add all of this up, and I get 65. If I add those two up and get 110, that's going to be too much. Why? Because I've added 37 and 8, and then I've added 28, 25, 8 again, 4 to get 65. So I've added this 8 twice. So I need to subtract that 8 out so I can get the correct answer. And so that's 110 minus 8, so the answer should be 102. And remember, that's really 45 out of 409 plus 65 out of 409 minus 8 out of 409. And that leaves an answer of 102 out of 409. And that reduces down to about 0.249, which is about 24.9%. All right, I'm going to go ahead and stop the video. It ended up being a lot longer than I wanted it to, but when I start the next video, I'm going to give you a question that's on the test, the next test, that lots of people miss. It is an actual test question. So we'll start off there with the next.